Yep, sorry. I just had the microphone off. Alright, I was just writing formulas down ahead that we'll probably use as they come up. I'm going to wait again probably 2-3 more minutes and then we'll get started going through the first problem. And it's great to see all of you. Thanks for joining us. Hi Christina, hi Michaela. Good to see both of you. We'll get going in a couple minutes. Definitely make sure you have the document up if you've gotten started. That's awesome. Michaela, I saw you were off to a good start already. If you're just joining us, good to see you. Definitely let us know who you are in the chat. Hi Donald, good to see you, buddy. Alright, we're at 11:15. So I think we're going to get going here. It's recorded so people who join us late can catch up. It's good to see the 5-6 you we have with us. I think for most of this I'm going to wait for you all to kind of talk with us in the chat about what you think we need to do for each problem. So to get started, the first page you see kind of here gives us all of the formulas we're going to work with for the next couple days or the next couple assignments. We're going to be talking about area for some shapes, and then we're going to be spending quite a bit of time working with volume for some shapes you've seen before, like the cube or the prism. Maybe you remember the pyramid. And then also we're going to start showing some new shapes like cylinders, cones, and spheres. The key with all of these area and volume formulas is two understandings. First, area is something that measures how much space a two-dimensional object takes up. So if you think of flat shapes like rectangles, triangles, and circles, area measures how much shape do those flat two-dimensional shapes take up. Volume measures how much shape... Oop, I didn't fix that at all. Let's correct that. Volume measures how much space a three-dimensional object takes up. And I'm sorry that wasn't fixed yet. So if volume measures how much space a 3D object takes up, we're talking about things that you could hold or pass, or that real-world objects that you'd see. Things like cubes, prisms, pyramids, and then we'll start talking again about cylinders, cones, and spheres. These are all three-dimensional objects, and volume measures how much space they take up. So what we're going to be using for each of these, every shape we have has its own formula, whether it's area or volume, that helps you measure the area and volume. For the first problems today, they focus on area. These are two-dimensional shapes. And the first shape here, they're going to ask you to find the area formula for a rectangle and find its area. For this one, that's something that you've done for quite a few years, the area of a rectangle. Feel free in the chat to tell us how you would find the answer, what formula you'd use, in other words, and then what the area for that rectangle is. Yep, and I see Michaela saying base times height, Donald saying length times width. They both really mean the same thing. Sometimes we talk about base and we're talking about length and width. They kind of mean the same thing. What do we get for an answer when we're using base times height or we're using length times width? And DJ, it's good to see you. Thanks for joining us, buddy. I see Donald and Michaela are getting at an answer of 40 or 40 square centimeters. And again, you probably don't need a formula for that when you've worked with a rectangle in the area of a rectangle for a while, but I think the key to understand is for all of these shapes, no matter how complicated they get, if we start with the formula, plug in the numbers into the formula, then it's pretty straightforward even for the new shapes we're going to see later on. Our next shape, we have a triangle. Anybody want to identify for us both the formula that we need to use for a triangle and then also what type of area this green triangle would have or how much space it's taking up? Michaela's correct, and part of why Michaela's going to do well throughout this, I saw she took time before the YouTube lesson to go through work on this, which is great, Michaela, everybody who did that. She's right that 1/2 base times height, that's our formula for a triangle's area. So if we do 1/2 of the base times the height, in this case our height is 9 inches, our base is 10 inches. So we'd be doing 1/2 times 10 times 9. And if anyone wants to identify what they ended up with for a final answer for the area there for that triangle. I like that Michaela says 5 times 9, so she was seeing 1/2 of 10 would be 5. That's certainly one way to do it, and 5 times 9 gets us to an area. .45 square inches. Our last shape's the circle. That's what we worked on in 7th grade for area. We started to review that a little bit yesterday. So again, with a circle, you're going to want to start with like every shape, our area or our volume formula. In this case, the area for a circle formula. You could scroll up in the document. The circles here, our area formula is pi times radius squared. And then if the area formula is pi times radius squared, the big key for finding the area of any circle is to know what the radius is. What's the radius for the circle that we're working with on problem 1? So Donald brings up pi times diameter. Circumference, which measures the distance all the way around a circle, is equal to pi times diameter. But we don't want to be using that formula if they're asking us about area. Again, circumference uses pi times diameter. Area uses pi times radius squared. That measures how much space the circle takes up. As Donald, Michaela, DJ are all identifying, the big key for problem 1 there on the red circle is to see the radius is 4 feet if the diameter is 8 feet. So with a radius of 4 feet, pi times 4 squared. I'm going to pause for a little bit and let people try to arrive at the final answer for the area of this red circle. So feel free to identify in the chat, once you've reached a final answer for the red circle, what do you think the area for that red circle should be? So I see 2 correct answers. Donald identifies 16 pi, which would be 1 correct answer. And I think you're going to see on Khan Academy, they're almost always okay with you just leaving pi as part of the answer. A bunch of you use 3.14 for pi. DJ, Fatumata, Michaela all arriving at 50.24. They are also correct. So your final answer could be 16 pi square feet. It also could be 50.24 square feet. And they're both acceptable options. I think you're going to see for IXL they usually have you use 3.14. For Khan Academy they tend to give you an option to put either answer. Alright, that's great work. We're going to move on to problem 2. Problem 2, let me fix the whiteboard here, is going to focus now on volume. And most of our work in 8th grade is going to focus on volume, but you're going to see connections here when we talk about volume with 3-dimensional shapes. If they have rectangles, they have circles in them, you're going to see parallels to our area formulas and how they are part of the volume formulas. One big thing I need to stress, you don't have to really memorize formulas. It's more about understanding why those formulas work. The formula sheets will always be available to you. I've given them to you on page 2. So feel free to use this document at any time. You don't have to memorize the formulas. It's more about just identifying the shapes, finding the formula, and then being able to work with the formula. So for the first problem, and Ariana, it's great to see you. Thanks for joining us. Jefferson, good to see you. Thanks for joining us, buddy. For both of you, since we had a couple people joining us, we did the area problems for number 1 already. I'm going to scroll up a little bit. basically for each of those. I forgot to put the area formula here. We found the area by using the area formula for the appropriate shape, like a rectangle, a triangle, or a circle. We're about to be starting problem 2 together, where we're going to be working on finding the volume, which is how much space one of these three-dimensional objects take up. I'm with Michaela, I think, for the very first one. The name of the shape we haven't seen yet, but the volume formula that works for this shape is definitely volume, or V, is equal to the side length, S, raised to the third power, which means side times side times side. What's the shape we're working with here for this purple shape on number 2? And you can also at this point feel free, yep, it's a cube as Michaela's identifying, and if the volume is equal to side length to the third power, or side times side times side, what is the volume for this cube? Feel free to identify in the chat for this cube what the volume is. Michaela's right. I've got DJ identifying 64. I'll show on my whiteboard where I think a bunch of you got there. For this shape, it's so straightforward. You may not need to use the formula and write it out. But if S stands for side length and the side length is 4, all we needed to do is figure out what 4 times 4 times 4, or 4 raised to the third power would be. So we do get 64 cubic centimeters. Whenever we're going to do volume, since it's in 3 dimensions, we measure how many little cubes, or 1 by 1 by 1 cubes, fit in the shape. That's really what the 64 means, so you'll always see volume in the 3rd dimension, or cubic centimeters. Yep. So great to see Fatumata, Ariana, Donald, Michaela, and with all you. 64 cubic centimeters is the volume, or how much space that purple cube would be taking up. The next shape, feel free to identify the name of the next shape. It's this orange figure we're looking at here. The formula for volume that helps with this orange shape, and then we'll also feel free to identify once we get there the volume, or how much space this orange shape takes up. So I'll give a bunch of you a couple minutes to identify all 3 parts for this orange shape, and then I'll go right along with you on my whiteboard as we try to figure out the volume of this shape. And I'm with Donald. The fancy math name for the shape is a rectangular prism. Sometimes they also call it a cuboid. You don't see that as often anymore. But it's kind of like a cube, but the length, the width, the height are not necessarily all the same, and that's what we mean by rectangular prism. Does anybody want to identify for this prism what the volume formula is? Something you would have worked through in 5th grade and 6th grade a little bit with volume of prisms. Michaela's correct that length times width times height. You could scroll up here in the document if you need, but I think a lot of you remember the prism formula was volume is equal to the length times the width times the height. That'll tell you how much space the prism takes up. So in this case, length times width times height is our volume formula. The prism has dimensions of 4 by 9 by 5. And a bunch of you, Michaela, DJ, if I do 4 times 9 times 5, I'm going to arrive at 180. In this case, specify your units. I've been nice, I plugged it in for you already, but in this case it's 180 cubic inches. The next shape, I believe, should have done a pyramid a little bit. In 5th grade, 6th grade, you should have done the volume of pyramids for a short time. It's going to show up on your 3rd IXL assignment. So here we have a pyramid shown. And the volume formula for a pyramid is very similar to the volume formula for a rectangular prism. It's kind of like a rectangular prism, but it all caves into one point. And the volume formula we'll see for the pyramid has a lot of parallels to the volume formulas between the cylinder and the cone. For a pyramid, it's the same as the prism formula, length times width times height, but because it caves in, you need to multiply by 1/3, and that's the same thing as saying divide by 3. So I'm with Michaela saying 1/3 times length times width times height, and that's the same thing as saying length times width times height divided by 3, because that's the effect of multiplying by 1/3. So now you should be working out, if you don't have it already, working out the volume for that pyramid. And again, we see the pyramid formula. You don't have to memorize, but you'll start to be able to remember it a lot better if you realize the pyramid formula is just like the prism formula, except we need to multiply by 1/3 since the pyramid caves in and the prism goes straight up. As we plug those dimensions in, we have a length, a width, and a height of 10 inches, 8 inches, and 6 inches. For me, I know that 1/3 of 6, or 6 divided by 3, would make 2. So to get rid of the fraction, I'm going to simplify this to say 2 times 10 times 8. There's a lot of ways we could have done the multiplication out. You could have just done 6 times 10 times 8 and then divided the answer by 3. 8 times 10 is 80. 80 times 2 more, as Donald's identifying in the chat, gives us an answer of 160. In this case, cubic inches. So up to this point, all the shapes we've shown hopefully looked familiar. You've worked with them in 5th grade, 6th grade, 7th grade, and they're going to help us connect into the 8th grade shapes, which are going to involve circles in some way, shape, or form, but now talking about the volume of 3D shapes that have a circular aspect to them. So that's what we see on problem 3. We're going to work through the volume for 3 new types of problems. This is what you see on the later part, the second half of this week's Khan Academy and IXL work. They're going to talk to you about 3 new shapes. And Jefferson, awesome to see you with us too. Great to see that 160 answer from you. So these 3 new shapes, we'll take a second to take a look at our notes here, are the cylinder, the cone, and the sphere. The cylinder kind of looks like a jar, a can, something like a can of beans, a can of food. A cone, you may have seen, whether you're a sports player and you see you use cones in your practice, or whether you're in traffic and you see a traffic cone, it's circular but then it caves up to a point. Almost similar to how you see a prism and a pyramid are related to each other. And then a sphere, our last object, the sphere, is any type of perfect ball. If we think about a basketball, if we think about a soccer ball, those are all spheres. If you think about the Earth, as Mrs. Watson probably showed you, the Earth is a little bit squished due to the rotation and due to gravity, but the Earth is pretty close to a sphere. It's just elongated a bit. So these are the 3 new basic shapes we're going to introduce. And just like the pyramid or the prism or the cube, all 3 of these shapes have their own volume formula that we need to use. It looks to me like Michaela's a little ahead of us. She's already identifying. Am I correct, Michaela? You're identifying that this first shape here is a cylinder. And I do agree with her. A cylinder are any of these circular shapes that are in 3 dimensions that look like a can. So I'm going to go ahead and identify with Michaela. I agree with her. This first shape is a cylinder. And the volume formula, again, we don't have to memorize these formulas, but you'll start to see structure and almost be able to remember them without looking back at your reference sheet every time. But it's here anytime you need it. The volume formula for a cylinder is pi times radius squared times height. And hopefully you'll see the aspect, a circle's area, how much space it took up, was area equals pi r squared. So the volume formula for cylinder, since it's just a three-dimensional circle that has height to it, is the area formula, pi r squared, multiplied by whatever the height of that three-dimensional cylinder is. So that's the volume formula we need to be using. Hopefully right now each one of you is working out the volume of this cylinder. I'm going to start showing that on my whiteboard as well, and feel free to identify the answer in the chat if you think you've got the volume for this cylinder. I'm going to start with the formula. Can anybody identify the radius and the height for this cylinder? What is the radius and the height for this cylinder? Because that's the key two numbers I need to identify to use this formula. The radius is going to be that distance halfway across the circle, in this case the circular base for our cylinder, so it's a radius of 5 centimeters halfway across. Make the whiteboard a bit bigger. And the height, in this case, is 9 centimeters, so we'll be plugging in 9 for the height and 5 for the radius. And thank you, Jeff. Yep, the radius is 5, the height is 9. Good job identifying those. So now if the radius is 5 and the height is 9, DJ says 70.65. He might be right. I'm not there quite yet. I'll start moving along. Pi is 3.14. 5 squared makes 25. With these formulas, you are definitely welcome to use a calculator. You're going to see me do that with my Google calculator here. I need to do 25, the radius squared, times 9, the height, multiplied with pi at the end, or 3.14. DJ misplaced a decimal point, but I think 706.5, what I'm seeing from Christina, and basically saw from DJ. Just need to get that decimal point in the right place. 706.5 cubic centimeters in this case. It's a good mistake to be making, DJ. Just double check the math with calculators, I would say. It's really, really fine to be making a mistake like that in the beginning. Realize if I'm allowed to use calculators, I might plug those numbers in twice when there's quite a few numbers, like we'll start to see with these more complicated formulas. So 706.5 cubic centimeters is our answer for that first blue cylinder. Yep, thanks, Michaela. So that brings us on to this next purple shape here. Anybody want to identify for us the name of that purple shape? The formula that we use for that shape? And if that formula has relationship to any other shapes we're working with. That's blocked a little bit. So again, that purple shape, what's the name of it? What's the formula that helps us with that purple shape? And also in the chat, feel free to identify how is this related to some other formula. I'm with Donald. This shape is a cone. It's a pretty skinny cone. The volume formula for our cone, you could scroll up in the document. The volume formula for the cone is pi r squared multiplied by the height divided by 3. Other times you might see it written as 1/3 times pi r squared h. It's actually how I'm going to write the formula on my whiteboard. But that's the same thing as saying taking pi r squared h dividing by 3. That's the same as multiplying by the fraction 1/3. They both mean the same thing. Hopefully you recognize the similarity between this formula and the formula for a cone with the volume formula for a cone. Is 1/3 pi r squared h. You'll see that's very related. Pi r squared, the area of the circle, times the height, but then also 1/3 because it caves in, unlike the cylinder. And Donald, yeah, I do agree with you. Thank you for pointing that out. As you look, kind of the triangular prism runs length times width times height, same as the regular prism, then divides by 3, and the same thing happens with cylinder to cone. And again, we don't have to memorize these formulas, but you'll actually find you should be able to remember most of them without having to turn to a reference sheet after we do a couple of these problems. Hopefully the formulas make sense where they come from. So if that's our formula, the big thing is identifying what the radius is, what the height is, plugging those numbers in. I think you all understand that pretty well for those of you who were with me. So feel free to identify in the chat what your answer is. I'm going to go ahead and plug the numbers in and work that out on my whiteboard. DJ, that's a good question. R is going to represent the radius, and h is going to represent the height. And it's important to identify which one's radius versus height, because the radius gets squared and the height doesn't. In this case, the radius, remember, is our distance halfway across the circle. So what is the radius for the cone, or the purple cone that we're working with? It has a radius of 8 is not going to be the radius. It's actually going to represent the height, how tall the cone is. The radius, as DJ's got correct now, is 2. So as I plug the numbers into the formula, 2 squared, because the radius is 2, h is 8, that's what I'm going to multiply by. So in this case I end up with 1/3 times pi times 4, that's what I get with 2 squared, times 8. 4 times 8 is going to give me 32. 32 pi is going to get multiplied by 1/3, which is the same as dividing by 3. So at that point, I'm going to use my calculator now to figure out what is 32 multiplied with pi, and then divided by 3, because that's the effect of multiplying. Oh, and remember, we want to use 3.14 for pi. If I type pi to my Google calculator, it's going to actually use 3.141592, that big long number that you'll memorize. So if I use 3.14, I'm getting to the same answer as Donald. If I use 3.14 for pi, I'm going to end up at 33.49. The 3 keeps repeating. I'm going to just round off to the nearest hundredth, which in this case is 33.49 cubic inches. So that's the cone. You'll see that start popping up in later IXL and later Khan Academy assignments, just like the cylinder. That brings us to our last shape. It kind of looks like a volleyball, like a basketball, like a soccer ball, like a football, if we call football the correct name and not the American football. So what is the name, the mathematical name we use for the ball? We call it a sphere. Thank you, Jefferson. And the volume formula for a sphere if you remember, the area formula for a circle was pi r squared, and a sphere is like a 3-dimensional circle. So we see in the volume formula pi r cubed. Now that third dimension needs another radius in it. But also, due to complicated aspects when you go from 2 dimensions to 3 dimensions, the fraction 4/3, or multiplying by 4 and then dividing by 3, is the coefficient with the pi r cubed. So after you do r cubed, whatever the radius is, you're going to have to multiply by 4, divide by 3, and multiply by pi. Yep, and DJ's pretty much identified the formula correctly. I'd emphasize DJ, it's really pi r cubed, right? I'm going to write that as r times r times r, but you usually see that just represented as r cubed, or r to the 3rd power. So that's the volume formula we're going to use for the sphere, how much space that sphere takes up. And I'm going to make the whiteboard larger. I'm going to go ahead and just with you all, hopefully you're with me, pen and paper or your own whiteboard at home, and you're using this formula. What's the radius for our sphere here? In this case, the radius for the sphere. No, it's the first time we're looking at it, and we're giving you all 3 formulas, DJ. Totally okay, as we're getting familiar with. Yep, the sphere is a little different. It's the one that has r cubed, because the radius becomes the height. That's kind of one reason it's got r cubed, and the other ones have r squared times height. So our radius, I'm with Donald, is 9 here. So if the radius is 9, I'm going to plug that in for r. Instead of r cubed, it becomes 9 to the 3rd power. Some of you may remember back from exponents when we did some of the cube numbers. 9 cubed, 9 times 9 is 81. 81 times 9 more is 729. So this becomes V equals 4/3 times pi times 729. Samantha, it's good to see you. It might be a bit tough, Samantha, because we're 40 minutes or so into the lesson. But it's awesome to have you here with us. I hope you're doing well, Samantha. At the end of this, or even now, maybe, definitely at the end, you'll be able to go back to the beginning, and it'll make, I think, a lot more sense. But what you're seeing is we have different shapes. They each have a formula. And then we plug numbers into that formula based on what the radius or the height different values are for that shape. Right now we're doing the last one on number 3. We're doing the sphere, which is a ball-like shape. And the sphere kind of has the most complicated formula. It's the last one we're getting to. So the sphere says volume, the formula V stands for volume, equals 4/3, a fraction, multiplied with pi, multiplied with radius to the 3rd power, or r cubed. As we work through, 9 was the radius for the sphere, so 9 cubed gave us 729. And I'm going to do 729. At this point, I'm going to show you a little trick. I could do 729, multiply it with pi on a calculator, multiply it with 4, then divide by 3. I'm actually going to do 729 divided by 3. I'm going to take that 729 and do the divide by 3. And that makes 243. So it's going to be 4, because I've taken care of the divided by 3, times 243 times pi. And I'm going to emphasize there's a lot of different orders you could do this multiplication and division out. I just chose to do 729 divided by 3. That gave us 243. 243 times 4 is going to give you 972. So the answer for the volume is going to be 972 multiplied with pi. They've asked us to use 3.14 for pi, so I'm going to do 972 times 3.14. I've kind of run out of room on my whiteboard. But the answer there is going to give us 3052.08. So if I do 972 pi, which is the answer, but they've asked me to multiply out the pi, times 3.14, I get a final answer of 3,052.08. And in this case, we're measuring in centimeters, and volume is always cubic, so it's going to be cubic centimeters. That's our final answer for that sphere one. Donald, I totally agree with you. You could leave it as 972 pi. And on Khan Academy, they even almost emphasize and encourage you to do that. Just double check always what the directions say. I think sometimes IXL says use 3.14, but maybe they also let you type pi in for the answer. So both are correct. You could say 972 pi, or you could say 3052.08. Because pi is a bit more exact than 3.14, technically Donald's 972 times pi, that's a more exact and more accurate answer by a couple little decimal places. But a lot of times we end up just doing that out as a decimal and figuring out 3052. But both of them are correct answers, and as we said, Khan Academy will take both answers. And thank you for pointing that out, Donald. Alright, so I think at this point we're getting close to noon. What do people think? Do we want to, as a group, go through number 4 and number 5, or do you want to try to do number 4 and number 5 on your own? What do we think? Let me know in the chat. I'm sorry, I'm new to the YouTube stuff. I was blocking all the work on the sphere there. I'm going to put in some of our work that we discussed out loud just so we could see on the YouTube clip. That was a sphere. It was V equals 4/3 pi r cubed. Samantha says she wants to do number 4 and number 5 as a group. I'm happy to stay here and keep going through number 4 and number 5 if there's other people who want to do the same. Alright, so I'm happy to do them as a group, so we're going to take a look at number 4 now. That's that yellow box master's problem. And I'm going to give you all a couple minutes to try to work through number 4 before we start showing it as a group. But what I'm going to encourage you to do is feel free to type with us in the chat and identify anything you're seeing or that you think is helpful for other students to kind of work through this problem kind of on your own before I start showing you what I think are seeing answers from you all. So again, I'm going to give you a couple minutes. Try to work through problem 4, and then in 1 or 2 minutes I'll start jumping in with you, showing you or talking with you all about what you think, but definitely feel free to put into the chat anything helpful you're seeing about the problem. And Daniel, it's good to see you. Welcome. The cone, it is a cone, and the cone is upside down. I definitely agree with Donald about an upside down cone, so thank you for pointing that out. Yep, good to see you, Daniel. And is there anything else? It is very helpful to know it's a cone. Same volume formula as Daniel's saying works for upside down cones as regular cones. Is there anything else you're seeing here about this cone that might be helpful for your classmates to recognize? there is a right angle. That right angle is kind of proving to you actually that the 16 centimeters represents the height, because if it goes from the point, the vertex of the cone, to the base and it forms a right angle, that needs to be an exact height measurement. That's showing us that it didn't go slanted at all, it went exactly straight up, and 16 represents the height. It is measured in centimeters, and that's an important detail to always be picking up, Samantha, is what is our unit of measurement. Is there anything else about this cone that would be helpful? Daniel, I'm going to direct you back to the question that I kind of asked everybody. Taking a look at the cone, and maybe this would be more helpful. What's our volume formula for a cone? I'm going to put that onto my whiteboard at this point. But what is our volume formula for a cone? V equals 1/3 pi radius squared height, all multiplied together. Everyone agree with me there with me that the volume formula for a cone, 1/3 pi r squared h. What is the height and what is the radius for this cone? For the cone we are working with, what is the height and what is the radius? A big thing to recognize, I do agree, the height is 16 centimeters. And the radius is not 15. They've made the problem a little more challenging by giving you the diameter of 15 centimeters. And you need to recognize that radius is always half as big as diameter, which gives us a radius, as Donald is saying, of 7.5 centimeters. I believe Khan Academy IXL, as they get tougher, start to do this to you. They're not always going to just give you a nice radius number. Sometimes they show you the diameter, and you have to understand for any of these circular shapes that radius is always half as big as diameter. So our formula becomes V equals 1/3 times pi times 7.5 or 7.5 squared times a height of 16. I'm going to make the whiteboard a little larger now so we can see that clearly. That cone had a height of 16 centimeters. It had a radius of 7.5, so that's what went into our formula. At that point, the first thing I'm going to probably do is do 7.5 squared, or 7.5 times 7.5, which gives us 56.25. I'm going to multiply that by 16, which is the height. And that gives us a height of exactly 900. So when I do 56.25 times 16, I get 900. I get 1/3 times pi times 900. 900 times 1/3 is just like doing 900 divided by 3. And if 9 divided by 3 is 3, then 900 divided by 3 would be 300. That 300, remember, still needs to be multiplied with pi. So our final answer could either be 300 pi that would be providing an exact answer using pi. Or our final answer could be the result of 300 times 3.14, or 300 times pi, which gives us 942 when we do the 300 multiplied by 3.14. Yeah, I'm going to emphasize for this lesson went pretty far today. And we're at the pretty far part where there's much, much more challenging problems than where we started at. And they would make a whole lot more sense if you start at the beginning. So we're kind of pretty much almost done here. I might show the 5th problem for those kids who are still with us and want the challenge of doing number 5. But if you're joining us midway through, I'd encourage you to start from the beginning. I wish I knew more about YouTube. I don't know if you could do that right now or if you need to wait until we finish up in a couple minutes and then it'll post the whole recording to YouTube. But if you start from the beginning, I think a lot of this will make sense to you, but it'd be very tough to understand if you're just joining us in the last 5 or 10 minutes. They can go back. All right, cool, Donald. Thank you. Yeah, so if you're kind of just joining us, I know it's fun to be in the chat with us live. But this stuff's going to be pretty confusing right now if you just joined us and you didn't start from the beginning. I think even if you started from the beginning, our big goal today was really just to understand through problem 3. But hopefully even problem 4, if you're understanding how to do the cylinder, cone, and sphere formulas, hopefully you could kind of see how 4 is just adding one layer by making the radius tricky to see. For number 5, I put number 5 on here because towards the very end for Khan Academy, for a couple of the trickier problems, they give you the volume for a shape, and they make you use the volume formula to find out a missing dimension. So instead of telling you the radius and height and saying go find the volume, which is what the formula is best built for, they tell you the volume and leave one of the dimensions missing. When we have a situation like that, it becomes an equation solving situation. You need to combine what we're doing today with your peeling the onion or equation solving skills that you had from Mr. Neville last year and that we've practiced a bit as well. So for number 5, they tell us the shape is a cylinder. They tell us the volume of that cylinder. They tell us the volume, or V, which I'm going to put on the whiteboard, is equal to 1,243.44 cubic centimeters, or cubic inches in this case. They tell us the radius, R, is 6 inches, but we don't know what the height is yet. The height is unknown, and that's really what we're trying to figure out. That's a good question, Ariana. If I'm trying to do an exponent, the easiest way, how do I show this? The easiest way is for you to hold Control and hit period. So if I'm looking at the keyboard, if I hold Control and I hit the period button, that bumps me up to write small little letters. So I'll show you here as an example. If I wanted to write cubic, height is not in 3 dimensions, but if I hold Control and I hit period, that lets me write a tiny little 3. And then if I Control and hit period, it takes me back to the regular text afterwards. DJ's correct. Now, if we're thinking about this cylinder, the volume formula that we need to be working with, that I'm going to put onto the whiteboard. I'm going to make the whiteboard a little bit bigger here. As DJ said, is pi times radius squared times height. So the formula pi times radius squared, or 2 copies of the r, multiplied with height, always gives us the volume of a cylinder. And in this case, the quantities or the values that we know are the volume, which is 1243, and the radius, which is 6. So I'm going to plug those numbers into the formula. V is going to get replaced by the volume, which is 1243.44. I'm going to make the whiteboard a bit bigger for now so we can see this clearly. But again, the volume and the radius came from problem 5 shown to us on the shape. And that's going to be equal to pi times the radius squared. And in this case, we know the radius is 6, so I'm going to plug a 6 in for r. And we do not know the height yet. That's our goal in this problem, to figure out the height. So that's going to remain as h in our equation. And in doing that, now our equation goes from 3 different variables of v for volume, and r for radius, and h for height, to only one unknown now, the height. And this is a peel the onion situation where we need to solve for the unknown variable, or in this case solve for h. Our big goal is going to be to get h isolated all by itself. And Donald's correct. The volume, which is 1243.44, the radius is going to get squared first. I'd probably encourage you to do that. R squared, or 6 squared, is 36. So h is multiplied by 36 and it's multiplied by pi. I could divide by 36 right now, but I also want to get rid of the pi. So I'm going to actually divide both sides by 36 pi. So that way I can cancel out the 36 and cancel out pi and leave h all by itself. That means the volume, 1243.44, needs to get divided by 36 pi. This is just like working backwards. We got to the volume by doing 36 times pi times whatever the height is. So to find that missing height, we go backwards. We do division by that 36 pi. And I should know at this point that I'm doing 36 times pi, or 36 times 3.4, which would really be 113.04. So I'm going to take 1243.44 and divide it. If I want to do 36 times pi, make sure that that's inside parentheses if you're using a calculator like this from Google. When I take 1243.44 and divide it by 36 pi, I end up with 11. So again, this last fifth problem is going a lot further than you need for most of Con or IXL, but if there's ever a problem where they tell you volume and ask you to find a radius or a height, it's really a peel the onion situation where you need to plug in the numbers you do know to the correct formula and then solve for the one unknown. But again, please don't get freaked out by number 5. That was just there because at the very end of Khan Academy, by the end of next week, you'll see 1 or 2 problems that look like this. Most of the problems are going to give you a shape, and they're going to make you find the volume. So at this point, I think everything we posted for Khan Academy and for IXL, you're ready to do at this point. There's about 7, I think, Khan Academy assignments, and then there's 6 or 7 that are starred on IXL. Our goal is going to be over the next few days for you to keep working through those as far as you can. On Monday, which is a few days from today, I'll have our next kind of Google Classroom lesson, and similarly on 11 o'clock on Monday, pretty much every week, we're going to be meeting Monday through Friday at 11 a.m. for this. I didn't plan on doing Illuminate check-ins, but I think that's not a bad idea at all, Donald. My bigger plan was to kind of look at Khan, look at IXL if that's going well for all of you. Then you probably know this pretty well, but if you do want Illuminate check-ins, next Friday I can put something together, just so you can kind of see on your own how you're doing with this stuff. I appreciate the thoroughness. Do we have any other questions while we're here? Whether it's math questions, whether it's just what's going on in the world, whether it's about other stuff for Mildred, is there anything else while I'm here with you all that I can answer? I'll give you about 30 seconds a minute. If anybody's got questions, you can definitely ask them. It's been awesome to see all of you here. We've still got 10. Okay. It has been really good to see all of you. I think it's very impressive that you're figuring a lot of this stuff out at home, taking an hour or so each day to join us, keep learning on math. Daniel, my plan on the weekends was no live streams, but like you all, I'm kind of stuck inside. I don't get to go many places. So if you're doing math over the weekend and you have questions, the best way to get me is to just send me an email, and then I kind of respond pretty quickly. DJ, my hope would be that we still have graduation. Again, my hope, as I talked about yesterday, is that you all come back to school on April 27th. And if that were the case, we would definitely still have graduation. I don't think we'll ever be doing graduation over the phone. I would say wait and see for the next few weeks, see how things are going in the news, see how things are going from Boston Public Schools. Should keep updating on us if they plan to be open April 27th when our April vacation comes to an end. Alright, if we don't have any other questions, I'm going to sign out. It's been great to see all of you. And please keep, if there are your classmates who you text with, you talk to on different social media things, encourage them to be logging on to Google Classroom, encourage them to be joining us. I am completely with Daniel. Everybody stay safe. And definitely, if you ever need anything, always feel free to send me an email. Like I said, I'm pretty responsive. I'm around the house most of these times like the rest of you. So if there's anything I can help with, math or other stuff, definitely shoot me an email. Marcus, to answer your question, graduation will still happen. Like I said, hopefully we're back in school in a month. We will figure something out for graduation for certain. Hopefully that's live and in person, and we're back to normal in a month or 6 weeks or so. Alright, I think on that note, I'm going to stop streaming. Good to see you all.